On last week's newscast, Mark Ryan recapped the DPW's efforts to clean up the snowstorm that dropped nearly 20 inches of snow across the town. Earlier this week, we had the chance to talk to Joe Dellicarpini, meteorologist at the National Weather Service and NORD resident, about the science behind that storm and the ice storm that forced school closures last Friday.
So to kind of show what happened with the storm, it was relatively, fast moving. It started late Friday night and kind of wound down later in the day on Saturday. So, nearly a 24-hour storm, but pretty typical. This is just showing from kind of left to right the time frame. And this is about 10 o'clock in the morning. The storm is located well off Nantucket. By 1 o'clock, it hasn't moved much, but the central pressure is going down. These are in millibars, so we're about 975 millibars down to 972. By 4 p.m., it's heading into the Gulf of Maine, still holding about 972. And even by evening, it's in the Gulf of Maine, kind of sitting there. But by then, most of the snow was just about done, at least the heaviest snow. Now, we've probably heard the term bomb cyclone. It was kind of made pretty famous with the January 4th, 2018 blizzard, which was classified as a bomb cyclone. What we look for is a drop in pressure, and we use millibars instead of inches in weather. So the storm has to strengthen about 24 millibars in 24 hours. And in this case, the storm dropped 35 millibars in 24 hours, so it more than met the criteria to be known as a bomb cyclone. And what that really means, it just kind of helps us stratify some of the stronger and rapidly deepening storms from kind of our typical nor'easters that we see that move through. So this certainly was a sizable and strong blizzard for our area. Now, the reason we had heavy snow, we can get a little sciencey here. We kind of look up in the atmosphere at where the snowflakes are being produced, not near the ground, but up a little bit. And in this case, we go up near about 10,000 feet. And this is where the snowflakes were being formed. And there's a large area of what we see lift, and you can see it in this purple contour here. This is kind of an area where we have a strong temperature difference at 10,000 feet, and also what's called strong convergence. So if you can kind of make out these wind flags, they're blowing from the south and southeast here over the ocean, and over the coast and here in eastern Massachusetts, more out of the north and northeast. So these winds are converging in an area where we have a strong temperature contrast, so warm air coming in off the ocean and cold Arctic air over the region. That produces strong lift, and it also coincides with an area where we're producing big snowflakes. So when we get these large snowflakes, almost look like $half size, they can pile up very quickly, and that's exactly what happened. So from 10 o'clock in the morning, we started getting under this strong lift. About 1 o'clock, we were kind of under the strongest lift for the day, but even by 4 o'clock, it was still kind of hanging around before moving offshore. So we had a good 6-hour period of strong lift and big snowflake growth, and those two combined to produce really high snowfall totals across the area, and that's exactly what happened.
To find the full presentation, watch the NCM Community Channel or check it out on the NCM social pages.